Derivative of cubic functions y equals x cubed from first principle. There are two methods you could use every time you do first principle derivative, differentiation. Classical method, or you can just using the formula. I'm going to use do the classical method first. With the classical method, obviously, you don't need to draw the graph. I'm just drawing the graph to explain what's going on. So this point will have a coordinate of x, and that point here will be y. And this point here, let's just be another point, so that will be x. So this is x plus delta x. And if I draw that line there, that will be y plus delta y. Delta means small change, just a tiny little bit change. And this distance here, as you can see, if that's x plus delta x, that implies that that distance here is delta x. That's a small change. Delta means small change. And that distance here, and that distance, the height, is delta y. So delta means small change. So that's what that meant. With the classical method, what we tend to do is we say, okay, well, we have y as equals x cubed. Therefore, y plus delta y will be equal to x plus delta x cube. So that's all we did. We just replaced y with. So we're looking at that point. That's y. That's for that point, y and x. Now we're looking at this point here, the coordinate here. So the coordinate here, that point, is x plus delta x and y plus delta y. So that's the coordinate at this point there. And the coordinate here is just x and y. So this one is for x and y, and this one here is x plus delta x and y plus delta y. So we need to expand this bit here. So the expansion there will be, so if we say y plus delta y equals, I'm going to expand that now. So that will be x cubed plus x squared delta x plus x delta x squared plus delta x cubed. Okay, so, and then I'll put the coefficient, the Pascal triangle coefficient, 1, 3, 3, 1. That's the expansion for these x plus delta x cubed. Now I need to take y to the other side. So we got delta y equals x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus y. But we know what y is. Y is x cubed. So that's x cubed here minus x cubed. So they will cancel out, right? Because y is x cubed. Therefore, delta y equals 3x squared delta x plus 3x delta x squared plus delta x cubed. Now I need to divide both sides by delta x because that's what we're adding. So if I divide that by delta x, I have to divide that by delta x, divide that by delta x, divide that by delta x. Well, so delta x cancels delta x. That cancels, you get 1 left. That cancels, you get 2 left. So now, finally, we get delta y over delta x equals 3x squared plus x. 3x delta x plus delta x squared. In the limit, that means when we squeeze this point, we bring this point down close enough to x. So we bring that point down enough. That means we're decreasing delta x, making it as small as possible, very close to become a tangent. So we know what a tangent is like. When we draw a tangent, it would just touch the surface of the curve. So we say in the limit, when delta x tends to 0, that means it comes to 0, close to 0, maybe you bring that point down from there all the way down to here. So it's really small delta x. In the limit, delta y over delta x will tend to dy over dx. So that's when we can say dy dx. We couldn't say dy dx until we got to this point. Now we have the authority to use dy dx. Therefore, dy dx will be equal to, well, delta x tend to 0. That means that will be 0. So that would tend to 0. That would tend to 0, which means those would disappear. 0 times 3x would be 0. So finally we get 3x squared. And that's the derivative of y equals x cubed. And that's what we're looking for. So a few things to bear in mind. Dy over dx is also called, because this is y, d over dx is actually an operator. That's what is the actual, and it's operating on y. So therefore we say y dot. Or sometimes you can call it f dash x. That means it's a function of x. So this operator is a function of x and it's operating on y. And then we call it y dot. So you might see in some books, you'll see y dot. That's what that meant. Right, so the tangent we're talking about was, if that was a curve, so now we draw a tangent to the curve. So we pick up a point there and we just draw a tangent like that. So that's what we're trying to achieve. Because in a curve, the derivative of a curve is different at every point. The gradient here is different from that, it's different from that, it's different from there, it's different from there, it's different from there, and it's different from there. That's why we have, when we differentiate, we have to make sure it's at a particular point along a curve. So that's why we're trying to make that difference between those 2 points as small as possible to approach that tangent. And that's why we have in the limit. And that limit is come close to 0. That's the limit here. And then we can have a tiny little rectangle there. Very tiny little rectangle. And that's what we've worked. And that's why we did what we've done. So that is the classical method of doing derivative used from first principle. Right, so we're going to use the formula method now. In the formula method, y is also f of x, which is x cubed in this case. And the dy dx is f dash x. That's what we call dy dx. And in the limit here, delta x tends to 0. Therefore, fx plus delta x, which is that one here, minus f of that one here, f of x, divided by delta x, the small delta x, or you might use h instead of the x. H is also same thing as delta x. So the h here is, so instead of having the x, you just have h, and you just have h here. So you may use that formula here instead of the one next to it. So you may use that, or you'll see that in textbooks, or you might see these in textbooks. So you might see this one in textbooks. So pretty confusing, right? Sometimes, but they're all saying the same thing. They just call the delta x here h. That's what they call it, and that's the difference. But they're the same thing. So you can call it delta x or you can call it h. Right. So let's use that method to operate on this. So we might use h here just in case, because in some textbook for the A levels you see a lot of those as well. So we say f dash x equals limit h tend to 0, f of x plus h minus f of x over h. So we are using this one now. Limit h tend to 0, x plus h cube minus x cube over h. That's the same thing. So we just replace that with x plus h now, minus x cube. The same thing we've done here. So we've taken away x cube here. That's x cube from the x plus h cube. So that one there. Now when we expand that, we still write limit. We always have to write limit h tend to 0. And then when we expand this one, we get x cube plus 3x squared h plus 3x h squared plus h cube over, that's minus x cube over h. So it's still the same thing. So again, still the same thing as we've done here. H is the delta x that we've divided here. That equals, again, limit h tend to 0. You can see the x cube cancels x cube. That's what you saw there. And you're left with 3x squared h plus 3x h squared plus h cube over h. In the limit, as h tend to 0, gets smaller. Right. So the h, we cancel h here. You can see h is a common factor. So h, that h, we cancel that h. That's what I meant. And that h also cancels that one. You get 1 there. And cancel that one, you get 2 there. Because if you take h out, that's a common factor, isn't it? And that h will cancel that h you've taken out. So I've taken 1 h out from there. Taking 1 h out. Taking 1 h out as a common factor. And then cancel with the bottom. So what do I have left is 3x squared plus 3x h plus h squared. Right, so that's what we've got left. As you can see, as h tend to 0, you can see that that will be 0 in the limit, and h squared too will be 0, and we're left with that. So finally, we'll be left with f of dash x will be equal to 3x squared because 3x h tend to 0 and h squared also tend to 0. So that's what we've got here. And came to conclusion that the derivative of y or f of x equals x cubed is 3x squared. You can see f dash x is dy dx. So either method is classical method or using the formula method. So that's the two that people will come across in textbook, different textbooks, but they're all the same thing.